And since I don't want to short, I just dedicated these 2 wrenches to this project permanently. If I ever need them again for some reason and it's not for this project, I'll have to cut the heat shrink off. But I would rather sacrifice a cheap, you know, hazard fraught wrench and Allen key to this project and just throw it in the toolbox that way for the rest of its days than to short out these terminals in any way. This is a 280 amp hour battery. How about we go and build it? So the specs on this battery, 280 amp hours. These are CATL cells. Over here, I have a 300 amp hour BMS, absolutely overkill distribution posts, and a case for it. You heard it right. We're building a 280 amp hour battery. The fact is I already built it, but I need to take it apart to make a couple of changes to the case that I built for it so that it's a little friendlier, and I also need to add a lid to the case to make sure that nothing shorts it out. My particular use case for this is simple. I am building a camper out of my pickup truck, and I need to be able to run a refrigerator and some fans to keep it cool in the summer, and maybe even an electric blanket to keep me warm in the winter, or at least in the late spring and early fall that is part of the skydiving seasons. I'm gonna disassemble this thing, and I'm gonna take you through the process of what I did to build the thing originally. Come along. Look, the standard disclaimers still apply. I am not an electrician, I am not a battery engineer, I'm not anything like that. I'm just an amateur radio person who happens to know the basics on how to build this stuff. If you're gonna do this, understand that you're taking this at your own risk, same as I did, took my own risk on it, and that there are real risks involved with it. So be careful with what you're doing if you're gonna go do this. The process that I'm gonna use is the same process for almost any battery that you're going to build. Whether you're building a 6 amp hour battery or something larger than 280 amp hours, the principles are still the same. There's an awful lot of energy available on these systems. Be careful, be very careful, and don't cause damage to yourself or your property while you're doing something that's part of our hobby. Now that that is out of the way, let's actually get into the details of the thing. When I purchased the cells, they were labeled as new but reclaimed from an automotive battery pack. I haven't had these cells capacity tested yet. My hope is to hand this off to one of the other YouTubers that has a capacity tester so that they can capacity test it for me, but that's not gonna happen anytime soon. In any case, when the cells originally came in, I labeled them individually. So you can see the number 2 on there and the number 3 on there and the number 4 on there, and there's a number 1 hidden right here. And I also labeled the box or the case that I made for each cell so that I know what cell goes where. These numbers also correspond to their cell numbers in the battery management system, little parentheses here, BMS, right? So that we're able to keep track of the health of each and every cell as we use this pack. One of the biggest things that I'm doing is I'm gonna round over these edges that I marked in blue because they're catching on things and making life difficult for me. So I set up my router on a table that I built, and I'm gonna round those over, and I'm also gonna build a lid and rebuild the base of it. Here we go. I don't know how well the camera is gonna catch it, but I marked in blue the edges that I need to round over so that I don't round over all the edges. So I'm gonna round over the outside edge and the inside edge. I haven't marked this one, but I'm not rounding over the bottom because the bottom just doesn't need it. It's just gonna be mounted flush with the bottom plate. I was going to build the floor for the box, or rebuild the floor for the box out of the same board that I made the box out of, but I realized it was going to be kind of a weird number of cuts, and since I'm a lazy guy, I'm just going to take a piece of plywood that I have handy I have the box over the piece of plywood. I'm just gonna rough it in. I'm gonna get my circular saw and just run that line, and afterwards I'll round the edges over again with the router. Good enough. Ha! Ta-da! Now comes the assembly. When I got these cells, they came with these tabs straight, and I think this metal is aluminum because it bends really easy. But basically what I did is I grabbed a pair of pliers and intentionally put the jaw of the plier as deep as I could get without messing into the cell, and started to bend. And after I had one portion bent, I bent the rest, and then to finish it off, here's the part where you have to be super careful. I used my bench vise, right? But you have to be careful not to short these two terminals. If you do, it's a bad day. Do these one at a time, taking the time to make sure that they're back to 90 degrees, because when I was taking the terminals off, I torqued one a little too much, and it got out of 90s, and the clearances I have on the box are based on 90-degree bends on these tabs. And as you can see, there we go. For what I did, and I realized it's overkill, is that after I bent the tab to 90 degrees, I took a file and filed off the corners to make sure that all of this was blunt and not gonna cut me, not have any sharp edges. Then I drilled a hole specifically to thread the same size bolt that I'm using. With that little bit with as thin as this material is, that really provides no mechanical grip, but it was a belt and suspenders approach. If I were doing it again, I probably wouldn't do that. I would just drill through, just big enough to get the bolt through, and then just use the bolt and the nut that I'm using to assemble everything. But since they're threaded, I have to be mindful now that I have to catch the thread when I put the bolts together. And again, I'm fairly certain this is aluminum because it is very malleable, very, very soft. If I strip a thread, I'm not gonna be heartbroken because I have a proper mechanical bonding between this and the jumper that goes to the next cell, or between this and the jumper that goes to the BMS. So I think I have done everything I need to do. I was going to add Kelvin taps to all of these cells, but I don't have the terminals that I need to make them. Kelvin taps would be used on here for the BMS leads so that it can keep track of the status of each cell. You can tell that the original pack where these were pulled out of had that on them, but they trimmed the lead off of them. And when I first built this battery, I had grand delusions of soldering those leads to this, and I'm not so good at soldering aluminum to copper. It seems. In an ideal world, I would have another hole drilled in these tabs for me to then put terminals on every one of those leads coming from the BMS, and then the BMS lead would be independent from the jumper. But good enough is good enough, so we're gonna keep on rocking the way it was. And as you can tell, I made this intentionally snug. These cells aren't supposed to need compression, but I talked to a couple of people that know a lot more about this than I do, and they all said, well, all but one said, yep, I would totally put compression on them. So I built the box intentionally snug so that I can put a block here, put a ratchet strap on, and then tighten everything down, before I put the screws in on the side plate. And I'm just using that ratchet strap because I don't have a wood clamp big enough to compress this together. If I had a couple of wood clamps big enough, I'd just use that. Ooh, fun. Just heard a crack. I don't have screws that are short enough for this, so these screws are gonna pop out of the side. I'm gonna have to take a Dremel to this and lop them off clean so that I don't end up cutting myself or hurting anything with that. So that's done. I'm gonna grab my Dremel and cut those. One of the things that I wanted to fix while rebuilding this was putting some heat shrink on all the jumpers. A couple of the jumpers already had it, but a couple didn't. So heat shrink on the jumper, it's a good thing. I'm gonna start with the most difficult connection, which is gonna be this terminal here because it's right up against the box. As I recall, I may have to take this apart to put this together because, yep, the bolt is longer than the clearance I have, and the box wrench won't fit and let me get that box wrench out, I don't think, if I remember right. Worth trying. Something I want to point out is that I have a few sets of Allen wrenches, and I found the right sized one in one of my spare sets, and I put heat shrink from almost the elbow all the way to cover the entire length of the arm, so that if this falls, it doesn't short out the battery. I did the same thing with the box wrench that I'm using for this project. It's boxed over here, open over here, and it can it's long enough to cross these terminals and short them. And since I don't want to short, I just dedicated these 2 wrenches to this project permanently. If I ever need them again for some reason and it's not for this project, I'll have to cut the heat shrink off. But I would rather sacrifice a cheap, hazard fraught wrench and Allen key to this project and just throw it in the toolbox that way for the rest of its days than to short out these terminals in any way. Time to get mechanical about this. Yeah, that's what I was afraid of. In this case, I think I'm just going to use the old trusty crescent and make sure to keep the handle on this side. That way it doesn't short out. I'm going to go ahead and finish assembling all these jumpers, and I'll bring you back at the end. A couple of things that I should have detailed so far that I haven't yet. I'm using, focus, come here, focus. There we go. I'm using nylon inserted nuts to mitigate any issues with vibration. Another thing is, these cells have positive marked on all of them. So this is the positive side of that one, that is the positive side of that one, and they're arranged negative, positive, negative, positive, so that my terminals both come out on that side, which is where I'm going to have the distribution blocks on. I have all my jumpers done, so I'm going from positive to negative, from positive to negative, from positive to negative. So I end up with a negative over here and a positive over there. It's time to mount the BMS. So I have the BMS on the outside of the battery because obviously there's no room on the inside. Ha ha! And I'm using, the screws that I have are too long for it. And since I don't want to pierce into the battery, because that'd be bad, I made some bumpers for it out of some rubber tubing. I want to say this is fuel line that I had left over from a project from fixing my mower. Just enough of the screw into the wood to keep the box. By the way, this is some kind of a food container thing that was in the kitchen. Don't tell my wife, okay? She hasn't missed it so far, so if you keep it between you and I, she won't find out. BMS goes in here, mess of cables. Considering putting these on because they came with the BMS. These are temperature probes, and this BMS has temperature protection on it. but I'm not sure if I'm going to do that or not. And by the way, the BMS has a port that is labeled B-, that's battery negative terminal. That's what I'm doing now. This one is the one that goes to the battery negative. And next I'm going to feed the load side into this box and attach it to BMS. And a little quick visual inspection. The heat shrink from this lead is definitely keeping anything happening here. So it's just a heat spreader for the BMS to dissipate heat. And then I have the Bluetooth module for it so that I can connect to it from my cell phone and keep an eye on this status of the charge. And now comes part of the fun, is putting all these leads where they go. The first cell in the lineup, or cell number 1, came with a 90-degree and a tab already built for this. So this cell must have been the first cell in the pack because it was already ready for a terminal. One of the things I wanted to do was to put some holes, and I forgot to do it until now, so I'm gonna go ahead and do that now. And that is so that I can feed these leads for the BMS into the battery area. I need to loosen this up. So I'm going to route that there, and then I'm going to take the excess and put it inside of the BMS box. But I'll do that. I'll do that at the end. So the battery is reassembled, and now we're going to check on the connection with the BMS, make sure everything is good to go. I just inserted the BMS results in there. As you can see, everything is all right with the battery. Next, I'm going to build the lid for this. For the lid for this, I'm going to put this battery on top of the piece of plywood that I got the bottom from, and then I'm just going to trace it out and then make notches for this and this in the process. I got ahead of myself. I need to clean up these wires. So I need to clean up the wires, which I just did. And I also need to put the distribution block on the side. So let me go ahead and do that now. And while I'm thinking about it, let me add the handle. I built the handle for this thing out of rope, and all of this should live under the lid I'm about to build. So I went ahead and built this lid. Fits just like so. There's a bit of a bump because of this cable here, but I'll have to live with it, okay? It's good enough. Put that in there. I went ahead and cut the excess of the rope off because the rope was also causing me issues. I'm gonna get some screws ready and screw it into the box, and I'll be good. Presto! Thanks to my patrons on Patreon for making the skydiving parachute mobile season a success. There you have it. This is not brain science or rocket surgery. If I can do it, you can too. Just be mindful and be careful with what you're doing and how you're doing, because there's an awful lot of energy in these things, especially at 280 amp hour per cell. Don't go doing stupid stuff and, hurting yourself or worse. I'll catch you guys on the next one. 7-3.